screencast as well, right? So in addition to whatever technical recordings happen through Zoom. So there are two approaches, right? So maybe you also had a chance instructions to go maybe through this example notebook. So what's the big idea behind these notebooks? So what you call them interactive coding. So we can write code, and we can write also some text. We can write some documentation or some notes for ourselves, for our colleagues, friends. But the difference is these two approaches is how where the data, where the computation, where the computer does the work resides. So the main approach will be using Google resources, meaning as you notice here, if you go through the home page of this course, right, is this GitHub page. It's a web page basically, right, and I believe you have a link to this. Right? Maybe you can all this can post it in the chat. If you this is going to be public after it ends. After the course ends, it will stay as long as Microsoft keeps the servers up. GitHub is owned by Microsoft. You will be able to access these notebooks. You will be able to go over again. So again, it's a good practice to do things over. So basically, in order to participate, if you don't have your Anaconda installation, you simply have to click on the appropriate part on this Open in Colab link. Right. You could say open a new window, maybe new tab, right? And only requirement is you have a Google account, Gmail account, right? You will be able to do live coding and eventually also save the results. So that's the main approach. But the second approach, which actually we mostly use ourselves as researchers, is this local approach where the code is run on our computer. So that's two approaches. Whether we make some other machine, the cloud machine do the work, and our computer is just simply a screen, a pretty face, right? Or we use our own computing resources. So Anaconda, those who install Anaconda, I'll show you briefly how Anaconda works, maybe a little bit, right? So you run your Anaconda launcher on a Mac or Windows, right? You get something like this, and you press Jupyter Notebook here, right? It's basically just a nice interface, nice interface for different tools, for research, for programming, but you want the Jupyter Notebook, you run it, and what happens when you press this button? Well, if you go to our web page, it will open up something like this, right? So notice the difference, right? You see up here, you see local host. That means there's a web server, right? This web page comes from your own computer, basically, right? It's being served by your own computer, right? So all the data actually lives here directly. You don't have to do any extra work, right? It's again. There are many positive sides. It works faster, of course, right? You get quicker answer because you're not connecting to some server in Finland or Germany, because I don't think we have any Google servers in Latvia. So this is local. So this is of course for more longer work. This is the approach to take. Right. If you want to do more research, it is eventually you will want to install Anaconda. Again. But of course, downstairs you need to install it, right? And then you basically get access to your own computer through a web page. Basically, you go through you get access to your home directory, your documents directory, right? I'm talking about Windows. Mac is very similar. And you go through, you find where you need to find where the files, where the notebooks are, right? So you go to BSSDH, you have to download it. Remember, if you don't have it, if you want to run it locally, you have to download. If you are not familiar with Git, you probably know how to clone it. But otherwise, you would just download the zip file, and you would archive somewhere on your computer, and then you would run it. So these are the instructions. Again, I'm talking. This is not required. If you don't have Anaconda, you don't have to worry about this. But I just wanted to go through this before we start. And then you navigate to your folder, subfolder. You open up, getting started. Right, it's already running because it already opened up. Right, and you have it somewhere like this is Google. This is what we're going to be using, and this is a local one. This is local one. So there's some difference. Notice, right? The Google made some design choices. They improved this a little bit, right? They made it prettier maybe, but the idea is the same. You have text, documentation, you have pictures, which are not code, it's just pictures, just some text, and you have live code. You have code, you can edit, and you can run it on your computer here. Okay, so basically, otherwise instructions will be very similar. The difference will be when we need to load data. That will be in the next part later on, right, when we need to load data. Because of course, if you're running on a cloud computer, well, the data for your work might not be there, right? So you will need to do some uploads. That's why locally, a local way, when you have your own corpus, you have data files, right? Locally, you have access directly. So that's the main big difference. But okay, so since everybody, the primary tool will be Colab in this workshop, so we'll be using Colab. Let me find it now while I can go through. Yeah, that's local. That's Anaconda. And where is my... And this is Colab. So this is Colab. Right. So again, this is a link. Everybody can. So if you run it, right? If you click on the link, again you get this link from here. Day1. This first one. Right. Again. You open up and you can start working. There will be one thing. So you will need to connect in order to have click this button here to actually let Google know that you actually want to work on this. Why is this done so? Because, well, people might want just to take a look, but they don't actually want to do any work, right? And of course, these are computing resources. By Google, it's a free service. They don't want you to, if you're not going to do any work, well, why even start, right? Why even get out of bed, right? So that's why you need to connect, and then you'll see there's a machine. If you look at the mouse, is everybody able to follow, right? You'll see you have 12 gigabytes of RAM, a machine somewhere, right? About 100 gigabytes of hard drive space. It's actually 40 of that is taken by whatever needs the operating system, by notebook, all the files that come in. So you have about 60 gigabytes of space. That's pretty nice, right? It's a free resource. What's the downside? Again, there's no such thing as free lunch. So downside is if you go away when you go to lunch, it shuts down after 30 minutes of inactivity, right? So it is basically, you will want to maybe save the work before we go to lunch, for example, right? And you will also have data also. If you're working with some data files, you'll want to download them to some local resource. So that's the downside. In fact, there is also a paid version of this. I think it's $10 a month, and there's even a pro version. I think like super. There's a pro version for 10 euros a month, and there's a 50 euro version. But interestingly enough, they still don't guarantee you. They stay up longer, but they still don't stay up forever, right? So you gain some more. You get access to stronger computers, right? But you don't actually get access forever. So again, it's something you do a lot of work. Again, we have an associate artist here in the back. Hi artist, right? Who use Colab, right? So it's nice. It's convenient. Again, so what's the big advantage? You can use this theoretically from your phone, right? Because you just have a website, you just click a link, and you can start even coding on your phone or even on your watch. You have a smartwatch, right? And because again, it's just a terminal. Your computer is just a pretty face to look at the connection to the cloud, right? Again, the cloud basically is other people's computers, right? So okay, let's get started. So everybody has at least their local notebook open in Anaconda, or possibly they have, of course, usually have to open here in Google Colab. Right? Is everybody good? Yes.
So we expect everyone to follow along.
Yes. So idea is you can follow along. And that's why, sometimes it's nice to have two computers right here, even with one computer, the notebook, right? I'll be going along, you will be able to go along as well. So, yes. So, we have a little comic here, why Python, right? About Python. They're saying that, well, Python gives you not wings, but you start flying in this comic because it's considered it's a professional language, it's a programming language, but it is relatively simple to use, actually. Right? It's a great starting language. You never programmed before, right? Again, this course is not for making you a programmer, but to at least get some ideas what's involved in giving instructions. Because programming is basically giving instructions to a computer in an organized manner, right? So that's all it really is. There's nothing like super magical. I mean, it might seem sometimes a little bit magic, but it's nothing. Computers actually are quite stupid. Actually, sorry to say that. They only do what we tell them to do, right? They don't understand what we really meant to do, right? That's one of the big issues in programming and coding is that they are extremely exact, right? If you forget to have a little comma or a parenthesis or bracket somewhere, right? It is going to give you an error message, and then you panic and say, what's this, right? But there's nothing to be worried about that. So we'll get started, right? So notice again a few more difference. If you using column, you also get access to table of contents left side, right? If you're using Anaconda notebook, I mean Jupyter notebook locally, you won't have this table of contents, right? This is just basically a table of contents. You can go through and you can jump around actually to this, right? But we'll get started with Hello World. Right? I'll close the table of contents, right? Hello World, right? So notice these little arrows here, right? If I press this here, right, you see some cells, right? So each of these boxes, right? That's a so-called cell or one unit. One unit basically, data, right? Yeah, it's all looks good. So let's get started with our first code for today. Of course, it is going to be Hello World, right? So how many people have written Hello World before, right? Well, everyone, okay. Also, everyone here is already an expert, right? So, okay, but we'll do it here. Again, any language you want to Hello World, right? I guess it's called a soundness check now, right? It's not sanity check, but soundness check now. So, basically check if everything's working, right? So, what you do here in Google, you press this little button, right? And it will run the code, right? And notice there's a warning. This notebook was not made by Google, it's made by us, right? By me. So, because it comes from this public site, right? So technically, right, at some point, if it asks data somewhere locally, right, it could ask. But of course, here we are going to deal with your data, so it's fine to run, right? And it actually runs, right? So, of course, first thing you want to do is I want you to write some greeting of yourself in this next cell. So how to do this, right? You write something, print, right? Parenthesis. You put brackets. You need to put quotes, right? Again, computer says exact. I'm trying printing a greeting now. Something. Hello. The BSSDH perhaps or something like that. Right. Print the greeting, and then you want to run this cell, this code, right? This little tiny program. You want to run it. So let's see what happens. Right. So as those who are more experienced, those who like shortcuts, and again, I love keyboard shortcuts, there is a shortcut, right? Well, I don't have my head to hold the mic, I guess I'll put it here, right? Actually, I guess a headset would not be such a bad idea, because I do need two hands, so can you hear me still, right? I don't know, maybe. Yeah, maybe, yes, for now. And let's see, so you notice here, it says run, Control, Enter. There are actually, if you look at here, tools, keyboard shortcuts. See here, right? There's a lot of keyboard shortcuts. You can actually set some yourselves, right? And they are for most part locally and publicly they are very similar, right? So if you are on a local machine, again here, right? This is local one. Again, very similar help. Keyboard shortcuts, right? Very quite similar, right? Quite similar. But again, you can use using Colab, so. Shortcut. Control Enter, right? That's a nice shortcut, right? You can also restore defaults, cancel. Right. So if I do something like print hello BSSDH 2, right? Again, notice how I write, right? Maybe I'll make it bigger. No, it's like this. Okay, so you see this, right? Is everybody able to see the screen actually? It's kind of tiny, right? So maybe we'll watch the font to be nice. So I press Control Enter, right? And it runs. Notice this little running symbol, and well, it run. Notice also on the left side, Google tells you how long it took to run this cell. 0 seconds, that's good, right? That means nothing much to do, right? So, okay, everybody's able to run their little code? Yes? Yeah, no problem. Okay. If you experience any problems, let me know. Right. So let's try to get some errors. I will need my two hands. Let's leave it like this. If this is fine. Yes, sound is okay. Yeah, okay. So that's easier. So let's try to get an error, right? Let's try the error because that's most of the things. What happens when things go wrong? Let's say if I do not good. Notice by the way, if I start writing something like this, right? Even call up, it automatically completed my parentheses. I open parentheses, it closes, right? Because if you open something, you need to close it, right? So same thing as brackets here. So it's kind of hard to make these errors, but it happens sometimes, right? So if I make this error, not good, right? So even have a very nice wavy line, right? Something's not going to be good. Don't run it, okay? It's not going to be good, right? And end of. So EOL, you get a syntax error, right? Again, are very exact. End of line while scanning string literal. Again, it gives you a little caret symbol, right? Tells you exactly where the problem occurred. Sometimes errors are maybe occur a line before, right? In this case, it's exactly you see exactly where the problem. And EOL stands for end of line. So basically, it couldn't find where to end, right? It keeps scanning and it can't find the end. So of course we fix it. So let's try to get a different error. Let's try to get a different error. Not good, right? Of course, it's good. So good. But if I forget parentheses, right? Again, maybe happens. Look, it's like this. Unexpected EOF, right? Again, in the file, right? While parsing again, it can't find the end. Again, similar error. And how about this? If I miss, we have typo. Happens to everybody. Pint, right? Again. So pint is not good, right? Name error. Basically, name pint is not defined, right? So sometimes the hardest errors to catch are when if this pint was defined and you type and it actually works almost like print, this would be the problem, right? When you had it works, computer works, but it does not. Sorry. And it works, and you don't get the right answer. So that's the worst thing to happen, right? When you actually when there's no error, but computer keeps working, but you didn't get the right thing. So maybe all this can continue a little bit, right? Maybe for a little bit. Yeah, switch for a little bit, right? You have everything works, right? So with the errors, right? I'm sure you can do this, right here.
Okay. So let's continue. So we saw what happens when you get an error, and if we fix that error, then again the error message should disappear. I'll press Control Enter to run it. Okay. And it prints not good. Well, actually, it's all good. It worked. So the next bit of material here is about Python history. So Python was created by a man called Guido van Rossum in early 1990s, and he worked at a number of large companies such as Google and Dropbox. For example, if you use Dropbox, then Dropbox client software is written in Python. So you can write applications and use them at a wide scale. So Python is a serious language. And here is a link to the language reference. So if you need to look anything up, you can open Python documentation and search for whatever command or whatever information you need. For example, we can look at print command and so on, or we can find out that there is a pprint command, pretty print command, and then read this documentation about what this pretty printer command does. So that's Python language reference. So, well, if you see some need for information about Python, you probably will use Google search anyway, and end up on some question answering site, which will tell you what's the answer to the problem. And so why use Python? You can see that there are some cells hidden, and I open them up. Well, Python is, sometimes I say Python is a very good second language. So it's maybe there are languages that excel at some things and focus on something in particular, but Python is kind of a nice language for doing many tasks, many different types of tasks. And it's also been called a glue language. So there are many libraries in Python that you can use and do some machine learning tasks and so on, or text processing, as is the case for us here. You can also look at this chart of rows of major programming languages, and this is based on Stack Overflow, so a question answering site, question views in high-income countries, and you can see that the interest in Python has been growing steadily, and here it is even language number 1. There is also a language popularity index called TOBE, and Python is now, as of this year, Python is language number one for this index. So it is really a popular language. So what else do we need to say about Python? There are some links to this index. We can check what's the position of Python these days. And we see a list of popular programming languages. So Python is at the top, followed by C and Java. But well, C programming language is much more difficult than Python. So let's start with Python for this workshop. And let us know if you have any questions or if something doesn't work. Valdis already mentioned that there are different ways how you can run Python, and one of these ways is installing the Anaconda environment. Anaconda installs Python along with a number of libraries that can be useful, so you don't have to install them separately. They are already a part of this Anaconda package. It is also often said that Python has batteries included, so it's not just a programming language where you can write something from scratch, from start, but it has many useful libraries included in the Python software. So you just need to tell Python that you want to use these libraries. It's called importing. So you import a library, and then you can use it. We will see examples of that later on. Computers, as was said before, are stupid. They do what you tell them to do, and they do exactly what you wrote in your program. So if but in this case, stupid is good, that computers follow your instructions to the point. And with programming, so you at first you make it work, then you make it right, and later on you can optimize the speed as well, but that's not that necessary often. And there is also this garbage in, garbage out principle. So again, whatever you write, the computer will execute, and you have to make sure that your data is clean, that you work with, and so on. And finally, there are errors. Sometimes you will see error messages. Don't be afraid of them. The message may already explain what needs fixing, and if not, then raise the sheets of paper or call for help from us or from people in the audience who have these black lanyards and who are ready to assist you whenever that is necessary. So here you can see an example of Python code that does nothing because it is all comments. So whatever follows this hash sign is a comment. So it's some text meant for you, meant for the user, maybe something you need to remember about this program code. And so here you see comments, and Jupyter Notebook has colored them green so that we can understand. Those are comments. They will not be executed. If I run this cell, it will not print anything because it's just comments. In real programs, comments should not explain what the code does. You can see that in the code. Well, you can write it, but they should explain why you are doing something. What's the rationale behind it? In this notebook, we will use comments to tell you some important things about program snippets that you will see. All right. So we have this Jupyter Notebook where we have text blocks. So it's just some text. And then we have these command blocks where we write programs. Python is interpreted language, and commands are executed as they come. You can see that in this notebook that we are just writing some code and then executing it as we go. All right. And here are some Jupyter basics. I should mention that these Jupyter basics or the shortcuts that you see in these Jupyter basics, that they will work for you in Anaconda. So in local installation, they might not always work in Google Colab. But Control-Enter will work in Google Colab as well. So basically what these are commands that let you interact with this notebook. So some shortcuts, so you don't have to press every time insert, code cell, insert text cell. But if you want to add a new cell where you have some Python commands to execute, you can just click Escape B, I believe, and there is a new cell. But if you would rather use mouse, you can add new cells where you can write your own Python code by clicking plus code icon here. All right. So we have Alt-Enter as well. That command executes the current cell and adds a new cell where we can write something. Well, is this meant to be an exercise for everyone?
Well, yeah, we only did one print, so I guess we can skip this exercise because everybody is able to print, so it will be the same type of exercise. I think how are we doing on space-wise? I think we're doing good, right? No chat also, there's no questions in the chat, so I think we can move on to variables, right, I think.
Okay, let's move to variables.
We have a lot of ground to cover, so
Okay, we did printing already, so let's move to variables now. In Python, well, in all programming languages, I guess, you may want to hold values, some information in some, well, you could say boxes with names on them. So these are variables. So variables give name to some value so that you can then use this name later on in your program. For example, here is my name is Valdis. Well, you should be telling that.
Write all this there.
Yes, I can write all this there. No worries. So what you see here is I'm assigning some value to a variable called my name. This variable then can be used in subsequent code in subsequent cells. But I have to remember to execute this cell, otherwise it will not work. So I executed this cell and
the variables.
I will create a new cell to check to print the value of this variable. So I will print my name. Good. And Control Enter. I guess I have to click this. Control Enter didn't work. Okay, it should work. Well, I will just press this Run button here, and you can see that Python program, the small Python program, took the variable value and printed it. So we have a way to store some text or some other values in variables, and we can use that variable later on. We can also use in Google Colab, you can press this X icon here and see what variables have been defined in your program. So this is a variable inspector. It will show you what variable you have here, and when I click on this variable, I can see, all right, it is 5 characters long, and its value is all this. So that can be helpful as well. And variables can contain different types of values. Up till now, you saw that we used text as a value, so some text enclosed in quotes. But we can also use other data types, such as numbers. For example, variable y will be 2019. Another variable, the answer is 42. Or my pi with some first digits of the pi constant. So you can see these are integer values without anything after the comma, and here we have a floating point value, so-called, which is a number with some digits after the point. We can also have Boolean values. For example, is hot variable is true. Well, it's not so hot here, but it gets hot outside. And then we can always, when we have a variable, we can ask Python interpreter to tell us what type of variable it is. So for example, the type of the variable, the answer is integer. And here you also see how I'm using these Jupyter notebooks, that I write some code in the cell, execute it, and see the result under this cell. Here is a little exercise for you. Create a new cell and ask or print the type of my name and is hot. just check what are the types of these variables. And we can just copy or look at example here. And I will also try determining the type of, say, MyPy.
Notice how it shows shorter. Notice those who are using Colab and also Anaconda that it is trying to give you suggestions. You type my, you see that it's giving you some of the already predefined like a suggestion.
Yes. So in this case, Jupyter is trying to help you, or Google Colab is trying to help you. And when I wrote my, it offers me a list of various things that I may mean by this. And I see MyPy here in this list that it offers. And let's execute it. And we will see that the type of MyPy is float. So that's the type of value for numbers with some values after the point, decimal point. And the type of, I guess you have already tried it. I will also check the type of is hot here. Let's execute it. And so the type of value of this variable is hot is Boolean. So its values can only be true or false. And let's just check what is the value of is hot. We can just write the variable name and execute this cell and see that its value is true. Now there are some names that you may not use as names for variables. So variable names cannot be reserved words, reserved keywords. And you can ask Python to tell you what these keywords are. So you can ask it for the list of reserved names. So they are reserved. You don't use them, but you can use any other names you can think of. Here, notice that we are executing command or function called help. Whenever you want to find out more about some command, you can ask for help. So you just write tell Python, help me with this help and print keywords. And let's do that. So I run it, and here is a list of Python keywords. And you can get more help by asking help and the name of this command. But we can ask for help about other things as well. So, for example, we used command or function print. So we can ask for help with the print command. Jupyter or Google Colab actually already shows you that help, but I will execute it in the notebook, and you can see that there is some explanatory text about this function print. So it prints the values, and it has some optional keyword arguments that we are not currently using, but who knows, maybe at some point we will need to use these optional arguments that you can give to the Python command. So we talked about variables and stored some values in variables, printed those values. There are various data types that variables or variable values can be. We will not look at all of these types, so we will not be exploring sets. But we will just briefly look at what is accessible in Python. So what types of values you may want to work with. So we have integers, for example 42. We have floating point values with something after the decimal comma, for example pi. So the type of this data type is float. We already saw that when we checked the type of the MyPy variable. Then there are Boolean values, string values. We started with strings. Then there are more complex but very useful types of values. One of them is called list. So a list can have a number of can contain a number of values. And here is a demonstration that a list can contain multiple types of values. So there are some integers and there are some text values. We will look at lists later on. So this is just a brief mention. And then there are other types of values in Python. One of them is called a dictionary. So it can store key value pairs. For example, favorite day, Friday, and so on. Then there are tuples, which are similar to lists. They can hold some values, but tuples cannot be changed. And there are sets that are an ordered collection of unique values. They can be useful as well. For more information about variables and different value types, here is a link to the Real Python resource. That's a good resource with many useful articles, and they have an article on Python variables. So we already saw the use of the string data type. So string data types are a type of data that we'll be working with today a lot. Well, because we are interested in doing some text analysis. And what should be mentioned about strings, that strings support Unicode. So you can use Python strings with whatever characters, whatever language you may work with. Anything to add here?
Yes, actually, yeah, no, everything's great. I think so far. I mean, of course, there are many things we can do with strings. One thing we haven't done yet is we have not immutable. We have not overwritten variables. Maybe that's something we have not yet covered. Like if you write a variable in Python, you can constant values, you don't really have constants. Really, it's basically you can overwrite the value at any point, basically. Right. So if you figure my name is Valdis, you can change the name at any point. Right. So. And also one more thing about the variables is about the naming. That's something is maybe not covered too much. What can be? We know what you can't write as a variable names, right? But what can be a variable? So naming, of course, is you start with an alphanumeric alphabetic character, and then you can add the numeric characters, basically, and of course you can't have space in a variable, right? You can use underscore. We didn't talk too much about underscores, right? So that's a little addition. For example, these examples written mostly more the names of like my name, an underscore, maybe about the naming, we can talk about that. The underscore, the snake case.
Okay, that's a good point. That we have to be careful what we use as a name of a variable. Here is an example about a text variable, so string, and the name of this variable is name. But you have to be careful not to use spaces in in variable names. For example, if I write my name equals oldest, when I try to execute this command, it will not work because Python will say, well, that's invalid syntax. We have to join this my and name together somehow, and a popular choice is to use underscore. So my underscore name is one way how you can name variables that's the name of which contains multiple words. And if I execute it, that will run okay. You can also use so-called camel case, so instead of underscore, you can say my name, just capitalizing the first letter of name, and that will also work. So don't put spaces in your variable names.
Fantastic. Yeah, one thing also, again, I didn't see any questions, but case sensitivity. So variables are case sensitive. So if you use capital letter, it will be different from not using capital letter, lowercase. So lowercase, uppercase, variable names will be different.
Okay. Yes, that's right. Sorry for all these small details before you get to actually work with Python. But yes, case is important. So upper or lowercase letters. So be careful how you write commands. For example, if you will try to type print with the capital letter print, P, then that should not work. And yes, we get an error saying name print is not defined. So you have to write that command with lowercase p, and then it will work just fine. So my name is oldest. Yes, if you have any questions at any point, let us know here or in chat. For remote participants, it's the chat. Okay. Now, when we have text values, strings, then we can do something with these variables. For example, we can ask for the length of the string with a function called len. And this function len would work with other types of variables as well. So you could also ask for the length of a list, and so on. So let's look at the length of name, and name is not defined. Why is that? Well, you may notice that when I run some Jupyter Notebook cell, that it gets a number assigned to it. So it's command number 25, command number 28, and so on. But here, this cell where we define the name Valdis has not been executed. So I did not run that cell, and therefore there's no variable called name. We can look at the variables here, and we have a number of variables, but variable called name is not among them. So let's run it. So name is Valdis. Let's print its value, and now we can ask for the length of the string. So first basic commands that you can use is length of value of this name variable. So you can also look at individual characters of a string. So for example, we can use the square bracket notation here, and ask for the first letter of the value of the name variable. And that will be capital V, right? You will notice that we start numbering of values from 0. So that's a convention in many programming languages that you start with element number 0, which is Valdis. and we can ask for element number 1, for example, and it should be A, and so on. We can also ask for the last character. So in that case we use index -1. So the last character in this string's value is S. Now let's move to string slicing, as it's called. So the ways how you can select some part of the string, or it also works with lists. So how you can select, for example, only a part of the name. Well, this shall we switch?
Sure. Yes. Okay. So we'll talk about slicing. Right. So slicing syntax is one of those greatest things in sliced bread. So to say, it's a great way of working with any type of sequence. So a string is a sequence of characters, right? We often need some subsequence slice from our string. So syntax is Python provides a convenient syntax to access parts of a string, and also we'll later see the same syntax will apply to lists and other structures. So let's try our first syntax. So we start at 0, and we are going to go to 3. So this means, but we are not including 3, which is 4, right? It's the fourth character, right? So let's check. It will be val, right? V-A-L. So 0, 1, 2. So that's 0, 1, 2. So one thing I should mention here, I'll make a new code, right? That it's often we use this 0 is not really. I mean, again, programmers are lazy, right? We don't want to write extra characters. So there's a convention. You can write this. It's exactly the same thing, and in fact, that's what you would do. So this 0 is implied. So and this reads very nicely, right? Get me the first 3 characters, right? It'll be the same thing, and that's what we usually want to write. Again, you can write the 0, but usually you skip it, right? Of course, if you need to start with second character, then you need to specify. So you start with the second character, it should be A, right? And so how far will we go? Right, so it's not going to include second, it's going to include third, but the fourth character is not going to be included, so it's going to be only AL, right? So we have AL, right? So let's look at some more examples. We can also use a negative syntax. We can look at the last. Let's say we want the last 3 characters. I'll get that. So last 3 characters would be name -3. And so this is what it means. So how to read this? So here we don't really write the last character. We say -3. And automatically, so we start at 3 characters back, right? And we go to the end. So we go to the end. So we start slice from 3 characters back, from 3 characters in the back, right? In the end, and go towards that end, right? So this is implied here. This goes towards the end. So if you typed this, right? So however, notice if I type name -3 -1, right? This will not give you last 3 characters. This will give you this will give you third and second character from the end, but not the last one, right? So this is very good. We have somebody has technical question. So D, right? So that's why usually you don't really. I mean, you could write, of course, you could write the index. So question now, if I'm using -1, right? So what would be my index for the last character if I did the forward? So name, say name 3, right? Name 2 is S, right? No, L, right? What would be the last character? My S, how do I get S only in the positive numbers? Well, I have 6 letters in my name, right? So my index would be 0, 1, 2, 3, 4, 5. So I will have type 5, right? So this is the same thing as this, right?
Same thing. Same thing.
So in slicing, so Python offers two slicing, two indexes. Right, two indexes. Right, start, one positive, one from the start, starting at 0, on 1, and one from the end, starting at -1, right? And this will be both SS. Okay. So let's go back to slicing syntax. So slicing, it offers us a way of getting some portion of this original string, and we want to slice it and get some letters. Question is now, so we can use anything as starting and anything as ending. I should mention also about errors. Like what happens if I do this? Let's see if we have 9,000. My name 9,000, right? What will happen? Probably an error, right? Yeah. Syntax index error. Why? Let's read it. String index out of frame, right? Well, we did this. Not that. I don't have my name not as long, right? So, but however, slicing will let you specify indexes out of range, right? So basically, I can do something silly like this. So name. Minus say 500 up to 800, right? So what will happen? What do you think? Right? I went very back and went very forward, right? And this is not an error. It's going to be my full name. It's my full name actually. Right. Yeah. So with slicing, you don't have to worry about going out of error, right? Of course, if you have a long string, this may be significant, of course, right? So of course, I mean it's not really maybe that useful, but just something to keep in mind. So if you're not sure, like so if I wanted to get my say again name, it's -3, and I don't know how to write, I could write 9,000. This will be my last 3 letters. Again, of course, this is silly, but so you would not write this here. I mean, it's not really needed here, right? So okay. So but there is slicing syntax. There's the third item, third optional. You could say a specifier or modifier. The third, which is step. So there is something called step. Right. So slicing syntax. Actually has a third optional. I should say specifier. I don't know, modifier. Step. So let's write this my name like this. VLI. So what happened here? Right. So we took every second letter. VLI. Right. So this is a step. It says how much jump from each time you encounter a letter, how far in the index you want to jump forward, right? So, in fact, this here, if you are perceptive, you are following, 0 and 6 are not really needed, right? Why? Because 0 is implied and 6 is the last one also, so we could do the same thing, right? I'm making new code. I could do the same result as this. So, like this. So basically I'm saying here, this is the start, this is the end, and I want to print all letters, starting from beginning. I can type. No, I can't type today. Sorry. From start, all the letters on, but skip every second one, right? So, and of course you can modify this VLI, same thing. So let's play with food, right? So potatoes, right? Who doesn't love potatoes? So PTTE. So what happened here? Again, same thing. PTTE, right? So how about this? We start with the second letter and skip every second letter, right? So from then on, right? So this will be O A O S, I think, right? Let's try this. Let's see if that's my hypothesis. Yeah, O A O S, right? So again, here. this "and" is implied, right? You don't have to write it. Right? It's the same thing as here. It's exactly the same thing. Slicing syntax again. This is something extremely common in Python, very much in use across many different data structures. So quite often, much more useful. And I mean, you always need you need to get some portion of data, right? And you have this access to slicing syntax. It makes writing when you use it quite makes your life more pleasant, I would say.
Okay, and we will later on we will work with lists. And slicing syntax works with lists as well. So you have a list of words, and you want to select just a part of this list. That's when slicing is useful.
Exactly. So there's one more thing about slicing. This is actually a question in job interviews. Used to be about reversing a string. How do you reverse a string? In some language you have to write some extra code. In Python it's extremely simple. So that's what you do. This is a Pythonic way of reversing a string. So we're going to take food. I'm going to reverse it.
So step -1.
Yeah, so basically we are going backwards, right? We're counting backwards. We're basically going backwards. We start at the end, right? And we go backwards, right? Kind of interesting way, right? And of course we can go backwards by 2 or 3 and so on, right? We can also step by default, step is 1, right? That's what we usually use, right? We don't specify it, but if we want to specify it, we can do positive or negative numbers, and it might be useful. Okay, so that's slicing syntax, a brief overview of slicing syntax. And I would like to move on to this mutability, right? Unimitability, very important concept in strings, because so far we have defined variables, right? We assign these strings. Well, how do you change string? Well, it turns out Python, among many other languages, does not let you modify string like this. Food. Let's see, I want to change my letter to X, right? This is not allowed, right? I can't do this, right? So this is going to say, you're going to get a nice message that string object does not support item assignment, right? So basically you can't just add a third character, can't just replace third character like this. It's not the strings are basically units. So basically what you could do, well, you can always override string, right? So there are a couple of ways of doing. We can do something like this, right? We can make a new food, right? New food. We're going to take the first 3 letters, right? This first two letters, we're going to add an X, and then we're going to add anything from forced on. So we concatenate, concatenate, right? So basically add together, right? First 2 letters from name food, then add letter. And symbol, of course, symbol X, right? Letter, and then rest of letters from food, starting with what? Is it third or fourth? This is fourth. Starting with the fourth character, right? So let's do this. So we have box tags also. I don't know, not very useful, but yes. So so that's how you could do it. There are other ways of working with changing strings, replace. We'll see some of the more of these operations later on. But yes, so you need to change. You can slice them together. And again, there's no. You can slice different variables together, right? My name and last name, right? Of course, right? Again, you could do this as well, right? My last name, right? Last name. Let's say, right, equals current, right, and of course I'll do, my Dietrich demonstrate my also supports other non-English characters, right, on, so we can add them together, right, and I can add them together with my name, right, or it's going to be Ulf's name, let's see, I'm going to say some, with my name, let's see, so full name is going to be my name, right?
Okay.
Yeah. And let's see something interesting here.
That's probably my name here.
Okay, so we're going to move this. I think this is my name, right? We can, of course, look here, right? I could see my name. all this, a name, my name. We have all this, lots of all this. There's one name. Okay, there's the name. Again, of course, I could also print it out, right? I can go up and check what I did. Right, so name, right, but will this be okay? What do you think will happen here? Well, this might be what you want, maybe not. Let's see. Well, this sounds okay. Maybe this is okay for you, but I probably want space. Right, so how do I add space here? Well, one easy way to do it, B. I'll copy this cell, actually you can copy it code. So you would want to, Control C, you would want to add the space, right? So easiest way, starting out, right, is just add space. Right. Something like this, right? So easy, right? On. Yeah, so I have space, right? Easy way to add. And notice again, so here I overwrote the previous value. So right now the value is with a space. Full name has a space. Right. Before it didn't have, so now we have space. Okay. More strings. Sometimes you have really huge strings. You need some new lines. Python offers a way of working with longer strings. So what do you do? Right. You use either three quotes or three small quotes, right? So you can print out a really long string, right? Let's see. Okay, let's run it, right? So let's see what happens. Let's see if we can print it, right? So long string. But again, in Colab, in notebooks, notebooks in general, you can always, you have a typing print gets tiresome again. So that's why in Colab you have access actually in Python repo. Again, you have the same thing. The last line, you don't have to print. You basically just type the variable and you get the value, right? Here, right? But notice something. There is a slight difference here. If you do it using this, it will show you all the special characters, right? New line here, right? It's here, right? If I do here code print long string, right? This will be.
It will be pretty.
It won't be pretty print. It will be prettier, right? This is for humans. This is for programmers, basically, right? So yes, so that's different. So you can see if you use this will be exactly. It will give you more specific information, but the print is more for human consumption print. Again, but if you're working as a researcher, you're working with data. Again. You want the last line in your each cell will be printed out, basically, or to the output, again in this programmer-specific format. Usually, yes, good question.
What's the difference between 2 and 3?
Which one? Which?
You can have 2 of those signs and you can have 3.
Quotes.
Oh, okay. So I was saying, so these. If you use 3 quotes, this indicates to Python that you want a string which could possibly go over more than one line. So you can write whatever. You can write whatever here. You can write what you want here, right? Otherwise, regular string you can't do that. You have only one line, right? In a regular, if you use another maybe this question in Python. Quotes and double quotes are function same, right? You can of course you start with a quote, you need to end with a quote. If you start with a single quote, then you need to end with a single quote, right?
And maybe we should just clarify that at the beginning of this cell, where you see 2 double quotes and 2 single quotes.
Yes, that's meant.
That's meant beginning quote and ending quote.
Yeah, maybe some fake. Yes, of course. So good. Like I said, there's not clear enough. Yeah. So basically, this right on this the function the same way, basically, right? That's what I meant here.
And for multi-line, you need 3.
Yes, you need 3 quotes. So also, of course, or also. This is same thing. 3 and 3. So you do 3 and 3. You can do multiple lines. Okay. So we'll cover some really nice addition in Python 3.6. There's something called f-strings. It's called formatted strings. And this also solves quite. It makes your life more pleasant, right? And we still have time, right? So, we had these names, right? I wrote my last name like this, for example. But what happens if I write a longer text? I want to insert some values, some variables. It will get really tiresome writing these pluses, right? Writing something like this. We have bigger text. Combining multiple strings, maybe you have some text you want to combine, it will get really kind of ugly looking. So F strings is this so-called formatted string literals. In other language, it's called string interpolation. So basically, we have some variables, we can add them inside create a string out of including variables. So let's see. My name, what's my name? Let's check, do we have that? Uldis, okay. Oh, we can stay with Uldis. Uldis, what's your favorite food?
Okay, I'll go with potato.
Also potatoes, okay.
Or you could say pizza.
Let's do pizza, right? And I'll do pizza, right? Okay. So we have favorite food, right? Right, pizza. Okay, so we have my name and we have pizza. So what the F string allows you to do is to write a string and put variables using curly braces inside. Actually, you can put anything in there, but also variables, and they will be treated as variables, right? So what you need, notice this little F, right? You put F in front of the string of quotes, you can put in variables, and actually some other stuff as well. So let's run it. My name is Uldis, and my favorite pizza. Great, right?
Cool.
So this is a really nice thing, right?
So basically, the names of variables get replaced by the values of these.
Yes. So let's compare it. What happens if I didn't have this, right? If I did not have this, right? If I forgot to put this F, right? What will happen? This is just a regular string, right? And this will be just a regular string. And no variables will be replaced, right? Interpolated. Okay. So here. My name is my name, and that's, just a string, right? So again, compared to this older method, right? The older method works, right? But you need to pay attention to spaces, right? It gets a little bit ugly, I think. Again, there are other ways of doing it, but this is still works. Okay, so let's say you want to save this string, right? Of course, you can always save it, right? So let's say food preference, I don't know, food string, right? Will be this one here, right? You can always save it, right? Here, right? So notice again, so anything inside is significant. Anything inside quotes is significant, right? So all the space, everything inside, right? So we can print it, of course, right? So put string, right? Yeah, my name is okay. So again, you can actually put anything in curly braces, also calculations, things like that, right? But I think variables will be good enough for now, because we still have more stuff to cover. Are we good with string interpolation? Any questions? Right. Okay. All right. So let's move on. So again, we covering quite a bit of ground today. So lists are the main data structure in Python for storing some sequence of data, anything, right? If strings are a sequence of characters, then lists are basically a sequence of items, of anything, of objects, right? So what are they? So they are your go-to structure if you want to store more than one item which is similar, right? So you can actually put anything. So they're ordered, so there's some order to them. They're mutable, meaning you can change items, individual members. And the syntax is basically comma separated, right? Square brackets, you have duplicates, and you can have nesting. So let's look at some examples. So this is a really simple list. So my list, and I created a list of numbers, right? So I could have done this like by hand, of course, right? But let's take a look here. So what I did, I used something called range. So what is range? Maybe you have help, right? Return an object that produces a sequence of integers. So range is something like a factory of numbers. It gives you numbers on demand, but it's not the list. In older Python actually gave you a list, right? In older Python for 2.7, right? But now it's basically a factory for numbers, so you actually create a list. You create, say, okay, I want a list, write a list. So that's one way of writing. And also, for example, let's write another list, my shopping list. Let's say shopping list, right? Will be, let's say, I'll buy chocolate, right? Milk, cookies, right? So this is also a list, right? Shopping list. Right. And again, chocolate, milk, cookies. Again, notice how I use double quotes, but when it's printing out with this also it's using single quotes. Again, there's no difference here. There's absolutely no difference. It's just it says these are strings. So I have a list of strings. So I have a list of. So I created a list of strings, of three strings, right? Again, can be changed later or as needed. Again. So again, the philosophically speaking, lists are meant to be storing similar items, but Python does not give you restrictions on this. You can put anything. You can store numbers next to your shopping list, right? If you want to buy numbers, right? Or something else, right? Store pretty much anything, right? So, and we have maybe some comments. I don't know. Let's take what can you do with lists again? We can use the same notation. We can use strings. We can use the slice notation. So let's take a look.
We can find element number.
Yes.
3 or whatever.
Yes. So let's start with 0. So first element in my list, right? Is going to be 11, right? How about my shopping list, right? Same thing, right? So shopping list, how about getting my last element? So there should be cookies, right? So cookies will be -1, right? Cookies. So, right. Okay. So first, last, right?
And unlike strings, you can replace values in a list.
Yes, that's one of the, like I said, mutability. That's the fancy word for saying you can change items. So I can say, if I don't want to buy cookies, so I can do this, basically, right? I change my mind, and I want to do. What do I want to buy? Potatoes again. Okay, potatoes, right? Capital, right? So. As you can see now, they're mutable. Chocolate, milk, and potatoes. Okay, why not? Right. So yeah, I can change values inside. Right. Same thing, of course, numbers again, and I can also add some things as well. We'll see that. So you can slice. This will be starting from the fourth element. So starting from the fourth element, right? The index 3, because they start counting from 0 again. That's the one thing is starting out. How are we doing this time?
We have 10 more minutes.
Okay, we'll continue this, by the way, after we'll keep going on this first notebook is longer than the following notebooks, because this is the basic material we have to cover, the most material. So my list, right, force, get every go backwards. Not backwards. Go to the everything. So everything, but the last two items. Right? This is skipping, right? Skipping. Yeah. This is again the same thing as before. So my name, right? Again, so same idea, right? It's exactly the same syntax, right? Except of course we're going through items. Right. So now, okay, like I mentioned, list. There's some methods. So what does it mean? We want to operate on this list. We want to do some. We want to change. It's mutable. Lists are mutable. We already saw this. We can change individual items inside, right? We can adjust, right? However, we might want to do some add some items. So let's take a look. So there's some items, there's some methods. So how do they work? Let's take a look. I have my shopping list, right? Let's check. Let's add something else to shopping list, right?
So these methods let you do something with that list.
Yes, and they will modify this list, right? They will modify this list, right? So something called in place, right? So I will add. Let's see, what should we add? My shopping list. What should I buy? So I will add. What will I add? Let's take a look at kefir, right? Why not? Right? And so shopping list. And it will be. There you go. There's kefir, right? Quite nice, right? So that's you can add multiples. You can also add more than one at a time. You can extend. You can combine two lists, right? So you can sort. There are many different methods you can use on lists. So this is one of those. How should I say? Fundamental structures of operating with any type of sequence of data. Let me see what else we show in operation. So how about sort? Right. So this will sort. That's a good question. What will happen here? How will it sort this list? I have my shopping list. Well, what do you think will happen here? So shopping list. Sort. Right. This will actually modify. This will sort the list. Right. So what do you think? What will change? Will anything change? Well. So chocolate, kefir, milk, potato. So yeah, it's alphabetical, lexicographical. Sorting, of course. So there's one thing is that, of course, the weight. But how is it sorted? Let's add something in a lowercase. Let's add something called what we call lowercase append. Let's add, I don't know, forks. Right. Okay. Append fork, right? Or maybe some dishes, right? So and now, of course, I have fork here, right? So question is now, an append. I will append. What else do we append? Well, let's try sorting. Let's try sorting. Again. Sort and I don't think nothing will change here because I see at last.
It will remain last.
Yeah, it will remain last. Okay. Right. Why is it not here? Okay, that's good. Why is it not here? Why is it the fork here? Why is the fork here? Well, there's an explanation for this one. Again, the question somebody? Oh, no. So ASCII table. This comes from old days. From question. Yes. Okay, great. Excellent. Okay, sure. All right. So you have to. So that's one of these things with notebooks, which is if you keep pressing, yes, I will have a lot of forks. Look at this. Fork. Right. I have 5 forks. I have 5 forks because each time it modifies this list, right? So I have 4 forks. So how could we remove these forks? I'll show you the easiest way. But I would do if I know I don't need these last 3 forks, right? I could do this like shopping list. List is equal shopping list. Everything shopping list. Minus 3, right? So I don't need the last 3 forks. That's one way of doing it, basically, right? If you know it's 10, you forgot. So remove last 3 items. So remove last 3 items, right? And we only have one fork, right? Okay, so basically I said, okay, this is a slice, and I'm just going to overwrite it on my new shopping list, points to the version of the slice of its previous list, right? So that would be the way I would do it. How we could do remove, I believe, right? So you could do this also. There's a remove, right? I used less. Always use remove.
I would do the same as you. I would use slice.
Yeah, slicing is more convenient because once you get used to it, it's very convenient. But you can use remove, right? So I have only one fork, right? Let's do this. Let's remove milk, right? You could do this, right? You can do shopping list. Remove milk. Right. On let's see, shopping list. So this I shouldn't have any. So there's no milk anymore in my shopping list. Right. The only thing is remove, I believe it throws an error. Yeah, it throws an error if there is no such thing as milk anymore. So you'll see an error if there's no milk before. Right. That's okay. I mean, so that's one way of doing it. It will look for this particular item and it will remove it from the list. So remove.
It will remove the first.
Yeah, it will remove the first one. It looks for the first one. Yeah, if you have three. So how would you remove all kefirs? Well, you write a loop, right? Oh, yes, you're probably right. We'll get to that after the break. We'll get to the writing loops will come after the break. We have a few more minutes. I'm wondering if we should start on dictionaries or should we finish? Actually, we only have 2 minutes.
Could you show also how we can check if some value is
incorrect? Yes. Excellent thing. So let's check. Do we have kefir in our shopping list? Right. So what you do is this: kefir in shopping list. Right? So this will go, look, true. So notice this is basically exact match. It has to be, this is exact match. So this is exact match. This needs to be exact match. Right? So we have kefir in my shopping list. How about milk? Do I have milk? In shopping list? I think I removed it, right? So I shouldn't have milk. So it should be false, right? So of course, also notice, again, just to drill down the point that it's case sensitive. This is kefir in my shopping list? No, of course not, because it's case sensitive, right? Case sensitive. So it should be false, right? There's no kefir, right? So milk in shopping list also is. So yeah, we'll use it. So checking for membership, it's called membership testing, right? Quite often used in keyword, right? In keyword you can check for something existing.
And that would work not just with lists, but also with other types of objects, for example, with a string as well.
Yes, let's check this. Yeah, let's check if, say, al in... Or let's say this, right? This in my name, I think it was all this and all this, right? Same suffix, right? So let's do that. This, right? True, right? Because of course, right? So it doesn't matter, right? Of course. So let's check is val. Or let's say al in my name. No, because all this doesn't have it, I don't think so. Right, it's false. And my name was name, I believe, right?
Yes.
So this is, again, this will work. In name will be true, right? So all this doesn't have all this does not have all, right? Substring. So substring checking, right? So again, very similar idea, right? You're checking a sequence of letters, of symbols, of characters, and here you're checking a sequence of some items, right? So okay, I think
time for a
break. We're gonna have a break. Maybe any questions with lists and strings?
No questions, everyone wants lunch.
So show hands, how many people are completely new to Python? Like how many audience has experience? 1, 2, 3, 4. Right. So some of you already have experience, so this is probably not too hard today, right? Just getting started. Okay, great. So I think we have a break. What's our program right now? Do we have any questions?
So if there are questions, let us know.
In the chat, you can write in the chat. We can go over them afterwards before start of the next. So next session starts at 1:20 or when is the next one?
1:20.
Yeah, 1:20. So yeah, lunch hour break. 1 hour. Yeah. Right. Thank you.
Okay. Thank you.